Alright, in this video we're going to be talking about some basics of trigonometry. Trigonometry is going to be pretty important in physics, particularly when we get to units on forces and projectile motion. So in this video lesson we're going to cover some basics of trigonometry, so that way when you get to those units in Unit 4, 5, and 6, you'll be ready to go. Remember, when you get to those units, always come back to Unit 1 if you ever need a refresher on some trigonometry basics. So let's go ahead and get started. First thing we probably want to start with is the Pythagorean theorem. Now this is one of your pretty basic trigonometry rules or equations. You've probably been familiar with this for a few years, but just in case it's been a while or in case you have never heard of it before, it's probably good to go over. So the Pythagorean theorem is a theorem or a rule that is going to relate all three sides of a triangle. And in the Pythagorean theorem, the sides are labeled as such. You have one side that's labeled A, you have another side that's labeled B, and then you have a third side that's labeled C. Now, it doesn't really matter if this side is A or B, or if this side is A or B, but what really matters is the fact that this side is labeled C. Now, once you've got those sides labeled, the Pythagorean theorem is as such. A squared plus B squared equals C squared. Now this Pythagorean theorem comes in handy a lot if you are ever given two sides of a triangle and are asked to find the third side. So for example, let's say I knew that this side was 3 and this side was 4, and you were asked to figure out what is the third side of the triangle. In this case, we would set it up 3 squared plus 4 squared equals C squared, and C is what we're solving for. To solve that, 3 squared would be 9, plus 4 squared is 16, and that's going to equal C squared. Now, 9 plus 16 would end up being 25, so 25 is going to equal the value of C squared. And then at this point, we would square root both sides, and we'd end up getting 5 as the value of C. Now, in this example that I chose really easy numbers, and in fact, the 3, 4, 5 triangle that's displayed here is one of your most common triangles. It's a nice triangle, it comes out to be nice values, and it's probably one that you should remember. So if you're ever given 2 out of these 3 values, you should be able to know the third value simply by knowing the 3, 4, 5 triangle rule. But if you're ever given some more obscure values for sides, for example, let's say A was 2.7 and maybe B was 3.9, you can use the Pythagorean theorem in order to figure out which side C is. What I'd like to do is I'd like to spend some time now going over what the different parts of the triangle are. So you might have heard this saying SOHCAHTOA. Sounds kind of funky, but SOHCAHTOA stands for or comes from this mnemonic device, SOH, CAH, and then TOA. Now, before we understand and explain what SOHCAHTOA is, it's important that we know the basic anatomy of a triangle. So what I've got on the screen here is I've got a basic right triangle, and I know it's a right triangle because I've got this little square in the corner. The square stands for 90 degrees, and so I will write that for this slide, but for every other slide we know that this is 90 degrees. And remember that the triangle, any triangle has to have all 3 of its angles add up to be 180 degrees. And so if this is 90 degrees, we know the other 2 angles here and here would have to add up to be 90, so then all together it would be 180 degrees. Now I'm just going to focus on one of the angles. I'm going to focus on this angle right here. A typical notation for an angle is the Greek symbol theta, and it looks like a circle with a line through it. Theta is one of the most common abbreviations or notations for an angle. So we're going to use this angle right here as our reference. So we're looking at a basic right triangle here, and we're looking specifically right here at this angle theta. Now, there are 3 different sides to a triangle, and they're all given 3 different names. First of all, let's focus on the side right here that is the longest of the triangle. This side is called, if you were not aware, it's called the hypotenuse. And I'm not quite sure if that's spelled correctly. I think so, but That's why I'm a physics teacher, not a spelling teacher. The hypotenuse is defined as being the longest side of a triangle. It's also the side, you'll notice, that's directly opposite the 90-degree angle. So if this is the 90 degrees right here, the opposite of that would be the hypotenuse. Now this is never changing. The hypotenuse is always the longest side of the triangle. What is changing is the other two sides. The remaining two sides, you have to reference to your angle. So like I said, we're going to be looking at this angle right here. And so maybe what I'll do is, just for ease, I'm going to erase this part right here, so we can really focus on the fact that we're just looking at this angle down here. The second side that I want you to be familiar with is the side known as the opposite. And the opposite is just that. It's the side opposite the angle you're looking at. So if the angle we're looking at is right here, or theta, then the side opposite of that would be right over here. And so I'm going to label that opposite. The third and final side is then known as the adjacent. And the adjacent side is going to be the side that actually is connected to the angle, but that's not the hypotenuse. So for example, if we're looking at this angle right here, theta, we already know that this side that's attached to the angle is the hypotenuse because it's the longest side. So therefore, the other side that's attached to it must be called the adjacent. Now remember, I said it is all dependent on what angle you're looking at. Let's suppose we weren't looking at this angle down here, but we were looking at maybe this angle up here. And instead of calling this angle theta, I'm going to call this angle alpha. Alpha is another notation that you might see for an angle. Kind of looks like a fish or sometimes a letter A. But we're now going to refer to this as the alpha angle. And so what if I was looking at the alpha angle? Well then, if this was the angle in question, then this side would be known as the opposite. And this side over here that's connected to the angle but not the hypotenuse would be the adjacent. So you see, it all depends on which angle you're in reference to. Notice, however, that the hypotenuse still remains the hypotenuse. Now knowing this is going to now help us with our trigonometry mnemonic device SOHCAHTOA. And what that means is, SOHCAHTOA, is that there are three trig functions that you need to be aware of. And that's what the first letter corresponds to. So the S corresponds to sine, the C corresponds to cosine, and then the T corresponds to tangent. And you'll notice that I am just writing the abbreviations that you'd find on the calculator. This is obviously not the full spellings. Now, we are going to reference an angle, and I'm going to draw my angle right here, theta right there. So I am wanting to find the sine of theta, cosine of theta, and then tangent of theta. And of course, theta is going to be some number. If you're in degrees, it's going to be some number 0 to 90. And if we're in radians, it's going to be something between 0 and pi, or pi over 2, to be more specific. In this level of physics, we are going to be dealing only in degrees. But if you go on to further levels of physics, radians will come into play. So we're going to only focus on degrees for this PowerPoint now. Okay, so we have sine, cosine, and tangent, and we're doing it of some angle theta, which is right here. Now, the rest of the letters correspond to the sides of the triangle we're going to be looking at. So O and H, we'll look at those first. So sine is going to be opposite over hypotenuse. So I'll go ahead and write that here. Opposite over hypotenuse. For cosine, and let me do it in a different color here, cosine is going to be adjacent over hypotenuse. And finally, tangent, which is the last one, tangent is going to be opposite over adjacent. So you can see how knowing the sides of your triangle really come in handy when you're looking at trigonometry. So let's go ahead and look at a couple of examples. Let's say we're looking at this triangle right here, and the theta is right here. And let's say we're looking at our special triangle of 3, 4, and 5. And I wanted you to find the sine of theta, the cosine of theta, and the tangent of theta. I wanted to find the exact values of these values. Okay, so already I know I'm referencing the theta. So I'm looking at this angle right here. So the first one is sine. Now if we go back, remember sine was opposite over hypotenuse. So I'm going to look at my triangle here, and since theta is what I'm looking at, I'm going to reference this angle, and I'm going to look, what is the value of my opposite? Well, it's 3, over what is the value of my hypotenuse? And it's 5. So the sine of theta in this example would be 3 over 5, or 3/5. Let's look at the cosine. We're still looking at theta, but cosine, as you may recall, is adjacent over hypotenuse. So adjacent over hypotenuse, and I'll do that in blue, is going to be the adjacent value, which is right here, the 4, over the hypotenuse value, which is 5. Finally, tangent was opposite over adjacent, and so in this example, the opposite value is 3, and the adjacent value is 4. So that's one example of some trig functions you might come into contact with. Let's look at another situation. Let's say we're looking at this triangle down here, and we're looking at theta, but specifically, I'm going to actually give theta a value. So rather than putting theta, I'm going to say that we are looking at a 30-degree angle. And let's see, I am telling you that this side right here is 10. And remember, this side is the hypotenuse because it's the longest side of the triangle. And it's assumed to be a right triangle here as well as up there. So we should draw those squares in. But the value of the hypotenuse is 10, and I know the angle. So in this example, it's a little bit different because I'm only given the angle and the value of one side. Now what we're asked to find is what is the value of y and what is the value of x. This is going to be a very common practice in physics. Okay, so let's first find the value of x. Alright, so I think, what do I know? Well, I know my angle, or my theta, and I know the hypotenuse. So right away, if I'm looking back at my SOHCAHTOA, my options for solving this are either going to be sine or cosine. And that's because I know the value of my hypotenuse. Tangent wouldn't be valuable here because I don't know opposite or adjacent. So I know hypotenuse, and so sine and cosine are going to be my options. Now, since I'm solving for the x value, which is right here, I'd ask myself, what is the x value, or x side, in relation to the 30-degree angle? Now, since the x side is actually touching the angle, but it's not the hypotenuse, that tells me it must be adjacent. So when I go back to SOHCAHTOA, not only do I know hypotenuse, but I'm looking or solving for the adjacent side. And so that tells me I'm going to be using cosine. So to solve for x, and I'm going to write this out to the side, to solve for x, I'm going to take the cosine of 30 degrees, and I know that that's equal to adjacent, which is my x, over hypotenuse, which is 10. Now at this point, we need to actually calculate what cosine of 30 degrees is. This is where a calculator would come into play. Now make sure that your calculator is in degrees and not radians, because that's a big mistake a lot of students make. So if you're using a calculator for perhaps pre-calculus or calculus, be sure you're not in radians. So if I take the cosine of 30 degrees, I'm going to get 0.866 approximately for the value of cosine of 30. And that's going to be equal to x over 10. And then to solve for my x, I would just multiply both sides by 10, left side and the right side. By multiplying the right side by 10, that would cancel out my 10s there. And so I would end up getting x has a value of 0.866 times 10, or 8.66. And just to double check to make sure that I did that right, I would just want to make sure my adjacent side, or x side, is not larger than my hypotenuse. And it's not. So I know that I did that correctly, or at least I have a pretty good chance of doing that correctly. So the value of the x side is 8.66. Now what we're going to do, and I'm going to erase this information right here. Now what we're going to do is we're going to do the exact same process, but we're going to solve now for the y side. I'm going to move that up. Whoop. There we go. Okay, so now what I'm going to do is I'm going to solve the exact same way, but now I'm going to do for the y side. So y, I'm looking at y, and there's a couple of different ways I can solve y. The first way is, you may have noticed, hey, now that I know two sides, I can use Pythagorean theorem. And while that will get you an answer that is pretty much accurate, if we look and notice, the 8.66 was a rounded number, right? We rounded that from the previous calculation. So Pythagorean theorem would certainly get us a close answer, but if we're looking to get the most accurate, I probably wouldn't want to do Pythagorean theorem. My general rule of thumb is go back to your original information, and that is, I know the angle is 30 degrees, and I know the hypotenuse is 10. So what I'm going to do is I'm going to take that information, but instead of using cosine, I'm now going to use sine, because sine, if you remember, is opposite over hypotenuse. And the y side right here is opposite of the 30 degrees. So I'm going to do sine of 30 degrees is equal to my opposite, or the y, over hypotenuse, which is 10. Alright, now I'm going to plug in sine of 30 degrees. Once again, make sure you're in degrees. And sine of 30 degrees is one of those special angles. It's probably one you should remember. It's 0.5. So anytime you take sine of 30, it's going to be 0.5. That's going to be equal to the y value, which is what we're solving for, over 10. Same thing as before. I'm going to want to multiply both sides by 10. So that'll cancel that out here. And then on the left side, that will go ahead and give me my new value of 5 as the y value. And once again, I know that makes sense because it's not larger than my hypotenuse side. And so I have now solved, using trigonometry, I've solved for my two unknown sides, my x and my y. The final thing that I want to mention in this video is inverse functions. Now, inverse functions are going to be functions of sine, cosine, and tangent, but instead of solving for a side, we are solving for an unknown angle. So let's go back to the example we looked at before, where this was 3, this was 4, and this was 5. In this example, we are aware of what all three sides equal, but we don't know what the angle equals. And so inverse functions are trig functions we use to solve for angles. And they look like this. So sine -1, or arc sine is an inverse function. And then there's inverse cosine, which looks like this, either cosine of the -1 or arc cosine. Whoops. There we go. And then the last one is inverse tangent, or arctan. So we would use these devices here, or these inverse functions, if we wanted to solve for an angle. Since we know all three sides, we can actually use any of the three that we want. It doesn't matter. And I'll show you what that would look like. So I'm going to go ahead and extend the page here, just so we have a little bit more space. And I'm going to go ahead and use the first one, which is inverse sine. So if I wanted to solve for theta, in this case, and I wanted to use inverse sine, what that would look like is inverse sine to the -1, and then in parentheses, you would want to put the values of the sides for sine. Remember, sine is opposite over hypotenuse. So go back down to here. In this problem, if we're trying to solve for theta, what is the opposite over hypotenuse? Well, the opposite is 3, and the hypotenuse is 5. So if you grab your calculator right now, and if you do inverse sine, which is usually the second function for sine, do inverse sine, and then in parentheses do 3/5, or 3 over 5, you'll end up getting that the theta is approximately 37 degrees. Now, just to show you that you can use any of the trig function, inverse functions here, I'm going to go ahead and do this 2 more times. The second time, I'm going to use inverse cosine. So if I wanted to use inverse cosine, and I still wanted to solve for theta, let's look at what the values of cosine would be. Cosine is adjacent, which is 4, over hypotenuse, which is 5. So it would be inverse cosine of 4/5. If you plug that into your calculator, do inverse cosine, which is the second function for cosine, and then type in 4/5 and press enter, notice you will also get 37 degrees as well. And then finally, if I wanted to set this up using inverse tangent, whoops, colon there, I would do inverse tangent, which is the second function for tangent, and then the value for tangent is opposite over adjacent, or in my example, 3 over 4. So if I plug that into my calculator, inverse tangent, and then plug in 3 over 4, I'm going to get theta is 37 degrees. So you're going to get the same answer no matter what. So it's just a preference of which one do you typically like to use. In this problem, you could have used any one you wanted. However, in some problems, you don't have a choice. For example, let's say I wanted you to solve for theta, and I give you the values of 7 and 9. And I don't give you the hypotenuse. Since I don't give you the hypotenuse, in this example, I'm only given an opposite and an adjacent. So I'd have to use inverse tangent and then plug in 7, which is the opposite, over adjacent, which is 9. And then let's say for this example, if I wanted you to solve for theta and I gave you 15 as the hypotenuse and let's say 8 as the adjacent. For this one, I'd have to use inverse cosine, and it would be 8 over 15. So it just depends on what they give you as the problem. So this was a basic trig video. Please come back and revisit this video if you need to review for any reason.